In order to make a capital budgeting decision, we need to be as objective as possible. And that means that we have to understand what the scenario is that's being discussed. We need to be able to identify the relevant cash flows, what the change is that's going to be caused by the decision we're going to make, and we're going to discount those cash flows back to some sort of a relevant figure. To be objective with this, we need to do it in such a way that everybody who's looking at this project would agree that this is the correct set of information. And therefore, the decision that we're going to make based on that information is one that everybody should be able to agree with. At its simplest, a capital budgeting proposal might look like the table that's shown on the slide in front of you. We've got a 9% hurdle rate, we've got a 5-year timeline that we'll be dealing with, and we've got an initial investment that we make up front of $1.11 million, $1,110,400 to be precise. If we're looking at the incremental cash flow, the benefit that this is giving the company over time, we've got that spelled out on the next line down for each of the 5 years, and then we've got something called a terminal value. The terminal value is what we're expecting to be able to sell this asset or this project for, or it's whatever the release of investment is going to be after we've gotten the cash flow that is generated by the ongoing project itself. We're going to add that to our last cash flow, and we'll discount each of those cash flows appropriately. So the total cash flow being discounted for any particular year is shown in the total CF line. We've got the year 0 with the cash outflow of $1.11 million for our initial investment. We've got the incremental cash flow for each of those years shown, and then we've got that 5th year cash flow plus our terminal value. If we go through the process of discounting that, we get the PV, shown in the PV line. If we add those up, we get the net present value. So we'll take the sum of those PVs and we'll subtract out our initial investment amount. We're left with a positive present value, in this case, of $100,900 and change. The internal rate of return we could compute from those cash flows is 12.24%, and we could even figure out what our payback period is, 3.91 years in this case. That's it. That's how you do capital budgeting, at least until you have to figure out exactly what all of those cash flows are. Life is never quite as simple as being able to look at the table and tell what the answer is. So here we go. Here's the rest of the story. More realistically, we're going to see a situation kind of like this. What you see on the screen is based on problem 1129 from our textbook, and it gives a fairly long paragraph of information. I'm not going to read the whole thing to you, but if you were to look at it, you'd see information about the existing machine and a new machine and depreciation and cash flows and other things. And then the very last sentence asks, what are we trying to figure out? Should they accept or reject the proposal to replace the machine? In order to figure out the cash flows and discount them properly, we're going to have to use this information to come up with a table that looks something like what we saw on the previous slide. So what I'm going to do is walk you through that. And our first step is this. Don't panic. First step in any sort of a large, complex problem is always don't panic. Rather, we're going to start small. We're going to take a look at what it is that we have to do and break that up into logical pieces. So there are several things that we need to understand. We need to understand what the scenario is. The scenario in this problem is to invest in a replacement machine, that's the proposal, or stick with our old machine. That's our business as usual situation. I use the letters BAU to represent business as usual. What happens if we don't make the change? We're going to need to identify our relevant cash flows, including the initial investment, the annual net benefit that we'd see, and the terminal value of the project. And then from that, we're going to determine what are the incremental cash flows. In other words, what changes because of the decision. To do that, what we're going to do is compare the relevant cash flows that we figured out, and we're going to compare it to the business as usual cash flows. In other words, if we go with our proposal and we invest in this piece of equipment, we'll have one set of cash flows, and we're going to subtract from that what the cash flows would have been if we had not made that decision, if we'd stuck with business as usual. Once we're given that, we'll have our incremental cash flows, and we go through the DCF analysis, the discounted cash flow analysis. That's the easy part. We discount the incremental cash flows at the hurdle rate, and we make some sort of an objective decision based on the criteria we have. We'll use net present value, internal rate of return, and possibly a payback period in order to base our decision.